Hello everybody, the goal of this short video is to show you some surprises of the computation time in Julia for some very simple operation. Please take a look over this code that does nothing new under the sum. Its goal is to calculate a weighted sum of a number of k equal 90 matrices of size n times n. Here the question is, if some students give me this kind of code in some class, should I penalize them? Should I give them a very small grade? Because let me execute it and please take a look over the calculation time. As you can see, I can still speak and continue speaking because the calculation time is very long. It's about 20 seconds or 25 seconds, and please take a look over the code in the meanwhile, because for each I and j you notice it's a simple sum. As you can see, I have 24 seconds, and this print line just printed this value. Now let me show you the time of computing the same calculation another way. Okay, let me compute the same in another way. As you can see, the time is close to 0.3 seconds. Let me print the last file I executed. Okay, as you can see, I generate the matrices in the same manner, but here I execute the calculation how, starting with these matrices which represent a 3D structure n times k, I transform them into a simple matrix of size n square times k. Then the real calculation is executed by this product, which is a simple calculation matrix multiplied by a vector. Sorry for my French here. And I reshape again the result in a manner so as to recover the results in a 2D matrix. And just to finish very soon, let me show you another file which does the same calculation as the last one, but the difference is that in this new file I do the same as above, only that I do no longer generate the matrices here. I consider that the matrices are already generated. So let me execute this last file, which is only computation vector matrix multiplication. As you can see, I can do it in 0.03 seconds. Again, 0.03 seconds, maybe the 0.04, and this is to compare with the beginning the very first solution, which is this one, which took 24 seconds. So it's if the ratio is not 1000, it's a speed ratio between 500 and 1000. The most simple solution for this calculation may be one based on using the sum, on using the standard library. This is this call, the sum call, which this is the most standard way to compute this. So if we started from 24 seconds, we ended up with 0.03. Let's just see this very standard method. And that's it. 0.07, let's do it again. 0.6. So I just conclude this short video by telling you that we can do the same calculation in Julia using a multiplication of a matrix and a vector in 0.03 or 0.04 seconds, maybe the most standard way without using loops in 0.6 seconds, and the school book manner in the most standard way to do the calculation can take up to 25 or 24 seconds. So you see the difference is really huge, and this was the only goal of this short video, to show you these huge differences, because they exceed my expectations. I knew I could expect some differences, but I wasn't expecting this scale.